Good morning and welcome to Tuesday of week 3 of your Physics 5 a day. We've got 2 motion practice questions today and then 1 big circuits practice question. Now the questions don't fit on the screen anymore, but remember you can download the PDFs from the website. Okay, so this is a nice question to get us started. Pause the video now to have a go yourself. And here we go. So this is a 2D suvat question, and the thing to remember about 2D suvat questions is that the horizontal and the vertical motion are independent of each other. We can treat them completely separately. So this is a very standard question to start. Explain why the horizontal component of the velocity remains constant. Because there's no force in the horizontal direction. No force means no acceleration. Okay, and then the second part, it's a bit more interesting. So the ball loses some of its kinetic energy when it hits the wall at B, and then it leaves horizontally. Well, if it loses some of its kinetic energy, then it must be losing some of its speed. So when it comes back off the wall, it's going to be travelling slower than when it hit the wall. And we're asked to sketch the path of the ball once it's bounced off the wall. And remember, we're treating the vertical and the horizontal components separately. So, compared to the journey from A to B, how does the vertical motion compare on the way back down? Well, nothing's changed in the vertical direction. When we hit the wall, we had no vertical velocity, and when we bounced off it, we had no vertical velocity. And the acceleration in the vertical direction hasn't changed either. So as far as the vertical motion's concerned, it's exactly the same on the way back down. It's going to take exactly the same amount of time to get back down to the ground. The acceleration is the same and the initial velocity there is the same as the final when it hit the wall. Okay, but the horizontal component is less when it leaves the wall than when it hit the wall. So that means that in horizontal motion, it's not going to cover as much ground in the same amount of time. And that means that it's going to bounce off the wall and it's going to take the same amount of time to get back down to the ground, but it's not going to cover as much horizontal distance in that time. Okay, and the last part of the question, explain how the time taken to travel from A to B compares with the time taken to travel from B to the ground. So we've discussed this already, but it's 3 marks. So we're going to say that the acceleration in the vertical direction is the same, and the vertical component of the motion is 0 when it bounces off the wall, and so it will take the same amount of time to get back down to the ground.